So when we look at compositions of functions, that's a little bit different than those combinations. Remember, a combination was something that we could do with just regular numbers. However, a composition, I'm going to have a variable so that I could plug into a specific spot. Right? So this is a little bit different. So when we look at a composition, the first thing that I want you to notice is the symbol. So the symbol is kind of like an open dot. A closed dot, remember, was meaning multiplication. An open dot now means composition. So when they say this, they say f of g, or they say g of f. So that open dot, kind of think about it as the word of. Okay. Now, we're going to read this a little bit backwards, meaning that if I have f of g, like in this first one, that means what I'm really going to do is I'm going to take g and I'm going to plug it into f. Okay, I'm going to take g and I'm going to plug it into f. Where I'm plugging it into is every time there's a variable. So I'm going to plug in for every variable. Okay. Now, if it's written g of f, that means now I'm going to plug f into g. Again, I'm going to plug in for every variable. So it's not going to change where I plug it in. It's just going to change which function gets plugged in. Okay. So let's do some of these and then see if we're understanding what's happening here. Right. So this first one says f of g. Remember that x just means that I should have variables in my answer. So I'm going to take g this time and I'm going to plug it into f. So the easiest way to kind of do this is I'm going to start writing f out, but instead of writing the actual letter x, I'm going to write an open set of parentheses. So it's going to look like x squared plus 1. So instead of writing the letter x, I just wrote an open set of parentheses. Now inside of that parentheses, I'm going to put my entire g function. So I'm going to put 3x plus 5 inside of there. Okay, so that's the composition that we want to look at. Now at this point, it's just about doing the math. So I need to simplify this function here. But this step is the whole composition so far. All right, so now let's look at how we would simplify this. Remember, if we have any value being squared, that means we need to write it twice. So I need to write 3x plus 5 times 3x plus 5, and then I've got that plus 1. Now I'm going to need to distribute. So all of this that we're doing now is just simplifying it. The composition is already done. So I'm going to say 3x times 3x gives me 9x squared. 3x times 5 gives me 15x. 5 times 3x gives me 15x. 5 times 5 gives me 25. And then I had that plus 1 there. Now I'm going to combine any like terms that I have. 9x squared, there's nothing to combine, but I can combine my 15x's, which will give me 30x. And then I can combine my 25 and my 1. So that would be my final answer. So I plugged g into f, and then I did some simplifying, some PEMDAS there. All right? Let's look at the next one. This one's going to be a little bit different because not only am I plugging f into g, but I'm going to substitute the number 4 in for that. Okay, so let's look what that would, or let's see what that would look like. So the first thing I'm going to do is I'm going to start writing the function g, but instead of the letter x, I'm going to put a parentheses, plus 5. Okay. Now what I need to do is I need to plug in f, but I need to use the number 4 to do that. Okay, so now I'm going to say 4 squared plus 1. Right, do we see what we did there? I plugged in my function x squared plus 1, but instead of using an x, I used the number 4. Okay, so now we're going to do our PEMDAS. Let's see what we can simplify here. So, right, I'm going to look inside the parentheses. I've got an exponent. So 4 squared is 16. 16 plus 1 is 17. Then I'm going to say 17 times 3. We've got 51 plus that 5. So my final answer would be 56. Okay? We're going to try another one of each of those to make sure that we really know what's happening here. On this one, I notice that I've got the number 2, so I should get a number answer in the end. I'm going to plug G into F this time. So I'm going to start writing out F, x squared plus 1. Instead of the x, I put an open set of parentheses. Now we're going to move to our G function and plug in a 2. So 3 times 2 plus 5. Okay, now we're going to do our PEMDAS. We're going to simplify here. All right, so PEMDAS says I'm going to look inside of parentheses. So 3 squared is 6. 6 plus 5 is 11. So I'm going to have 11 squared plus 1. 11 squared is 121 plus our 1 is 122. All right, last one. Let's look at it. This time I've got an x here. So that means in the end I should have x's in my answer. I'm going to take F and I'm going to plug it into my G function. So I'm going to start off writing my G function, open set of parentheses instead of that x. I'm going to plug in x squared plus 1 into that open set of parentheses. Now let's do our PEMDAS. I look in the parentheses, there's nothing there, so now I'm going to start by distributing. I'm going to get 3x squared plus 3. Then I had this plus 5 there. I'm going to combine my like terms. So I'm going to end up with 3x squared plus 8. Okay. So now we should be able to do those compositions where I'm taking one function and plugging it into another function.